Okay, I am going to be taking notes for lesson 12-6, which is on locus. So if you can grab your notes, get those out at the same time. This is, if we had an actual book, this is the actual last section of the book. But we will obviously skip a couple chapters, so we'll go back to those in time. But this is kind of a random last section here. And a locus is basically, as this first sentence says, a set of points all meeting a certain standard or certain condition. Okay. So what you're really going to be seeing are these little one sentence word problems, and you are going to just draw what is being described. And again, when you're drawing you're really just drawing points, but if you connect all the points, it looks like some type of basic figure. So let's go with number one here. It says draw and describe the locus. Locus is again is just a set of points that meet this description. In a plane, points 2 centimeters from line XY. Well, you can see obviously the line XY there. And if you were going to be 2 centimeters from XY, now you don't need a ruler and actually measure 2 centimeters, but I'm going to make a locus here in blue. But just imagine 2 centimeters away from it, and you would just be all of these blue points here above it, 2 centimeters. And because this is a line that goes on for arrow, these points I can tap it off with arrows here at the end. You don't need to make all the dots because all the dots would consistently make a solid line. The assumption here is that this is 2 centimeter distance above it. Some of you might have already been thinking, well, if it's 2 centimeters above it, couldn't it be 2 centimeters below it? And that is correct. This is the other set of what we would call locuses or loci. But it's just a set of points, although this is in the shape of a blue line, that fit the description. And this being the description. In a plane, points that are 2 centimeters from line XY. If they ask you to describe it, you would just say a line above and below line XY. Okay, so it's nothing really hard in terms of math calculation. Today's work, you'll see, it's a lot of just drawing. So let's see the next one here. Again, it's this concept called locus. Draw the locus in a plane, points that are equidistant. Of course, that means equal distance from 2 points x, y. Here's x and y. And if you were going to be equal distance from it, you would actually be on this yellow line here. Because any point on this yellow line, you are the same distance from the end point. I'm just kind of drawing. You don't need to draw these solid lines, but I'm just demonstrating that you're equal distance. I'm going to erase that in a second. But there's also another key to this. It also says that you need to be 2 centimeters from the midpoint. Well, that creates another issue here. We can't have all of these points. We've got to be 2 centimeters away from the midpoint and yet also be equidistant to the endpoints. Equidistance to point xy and 2 centimeters from the midpoint. And that would be 2 centimeters above it, 2 centimeters below it. And so in this case, the locus is just those 2 red dots. Okay. Finally here, we'll do one more and then we'll be done here. Draw and describe the locus of each in a plane. Now, when they keep saying in a plane, they are talking about a 2-dimensional scenario, like a piece of paper, as opposed to this one where it says in space, and this is when you go into the 3D land. You want to, for part A, the points that are equidistant from 2 parallel lines. Equidistance, of course, means equal distance. Those are the parallel lines. As you can imagine, you basically want all the points, and if I just connect all these points, it makes a straight line. That this straight line is right in between the 2 parallel lines, and it's parallel to the original lines itself, so that is the answer. The answer is just a visual. And again, today's work, you'll just be doing a lot of drawings. And then this one here, it says in space, 2 points that are equidistant from two parallel planes. This one would be a little bit harder. I might have run out of screen here, but there's two planes here at the bottom. There's plane A and B. And basically, you just want to be in between them. And I'm going to draw this as best I can. Another plane here that is ... That is in between the two original parallel planes. And then this red plane is considered the locus. Okay, and that will do it for this lesson and your notes.